Okay, guys, before we get started, let's do a little bit of housekeeping. Today, we're going to go over 3.6. Next lecture is 4.1, so the test will be open after that next week. So actually, it'll open up next week. We're really a day behind when we look at the lectures, which is fine. We can make that up as we go. I'm not worried about it, but realize this test only has 3 sections. So it's going to be 3.5, 3.6, which we're going over today, and 4.1, which we will go over on Thursday. Do you guys have any questions about anything from 3.5 before we get started today? Any questions on chat? Can you see that? Okay, well, if there are no questions, I'm going to start on 3.6, which is we're going to focus on the polynomial inequality, but specifically the quadratic polynomial inequality. Okay, and I teach this as I teach quadratics. Hold on, give me 1 second. Remember, inequality means we're going to deal with a greater than, less than, greater than or equal to, less than or equal to, all that fun stuff. And we'll get to that. But I really teach this in a graphing way. So the quadratic aspect, because we've graphed quadratics, we've solved quadratics, we've found vertexes, we know if they're smiling or frowning. We've done a lot with quadratics so far. It really just kind of builds on that. So this section won't take long because we have so much previous knowledge about the dang quadratic equation. Okay, so let's look at and I'm going to start with an example and kind of go from there to show you what I'm talking about. This is number 6 in the homework. Actually, I'm going to change it up just a little bit. X squared minus 4x, let's say, is less than -3. Okay, this is like number 6, but I changed it just a little bit. Okay, notice we have an inequality, right? Instead of an equal to instead of an equal to, we have a less than. Notice that this is a quadratic. We've got an x squared going on. That's the highest agreed term, and it's a polynomial, right? X squared, 4x, and -3. Those are all okay for polynomial equations. So if I want to solve this, now I'll tell you the answer for these is different than an equal sign, because an equal sign, you have a set number of answers. Like if it's a squared polynomial, we're gonna have 2 solutions, right? We talked about that a lot. Well, in this one though, we're gonna have an interval of solutions, and we'll get to that when we get there. But because it's an inequality, we're going to have an interval of solutions, or we might have no solutions. That can happen as well. Let's get to what I'm talking about. So to solve these, the first thing you have to have is 0 on one side of the equation. So I'm going to add the 3 to the other side of this equation. X squared minus 4x plus 3 is less than 0. So now I want to graph this equation. And we've done this a lot now, right? We found x-intercepts. We know the y-intercept's 3. We can find the vertex. We can do all kinds of fun stuff. The easiest way to do it is just pop it in your calculator. But I want you to pay specific attention to the x-intercepts. They're going to be called the boundary points. Your book calls them boundary points, okay? We're gonna pay special attention to the x-intercepts. So all I'm gonna do, I'm gonna be real lazy, and I'm just gonna pop it in my calculator. Go to my calculator. Go to y equals. Is there a little bit of a glare there? Okay, so go to y equals, put in x squared minus 4x plus 3, and I'm going to graph it like it's what we've been doing so far. And you'll notice, of course, we knew a lot of this stuff, right? We know it's going to be smiling because the leading coefficient's 1, so it's going to be up and up. It makes the vertex a minimum. You guys remember that from a few sections ago. We can find the vertex. It's negative b over 2a, and you plug it in. You got to kind of do the long way around the vertex. But really what matters for us in the inequality section is where it crosses the x-axis, okay? Trying to see where it crosses the x-axis. It looks to me like it's 1 and 3. An easy way to check that is the table. So if I go to table and I go to x equals 1, I know it's, if you go to x equals 1 right there, you'll see the y value is 0. So therefore that means we have an x-intercept there, right? And the same thing with 3. With 3, the y value is 0. So we also have an intercept. So x equals 1. 1, 2, 3, right? Now look, it looks like this right now. Now look, I'm going to use 2 different colors here because with inequality, what matters is what's above the x-intercept or the x-axis and what's below. So above the x-axis, I'm going to use green, okay? And then below, I'll use purple because I think it'll kind of show up a little bit. And it's not too different. It's kind of different, okay? We've got purple and green there, okay? Okay, now we need to go back to what the question is asking us. The question's asking us, where is this function less than 0? So what it's saying is, where are the y values less than 0? Well, the y values are negative or less than 0 below the x-axis, okay? So what we're asking here, actually what's really going on here is this purple line, not the green lines, the purple lines. Since it's less than 0, it's the purple lines. And we're going to write this solution in x values. It's an x interval, okay? And notice from x equals 1 to x equals 3 here, we're below the x-axis, okay? From 1 to 3, we're below the x-axis. So that would be the solution here, 1 to 3. Now, that's not a coordinate. That's an interval. So between 1 and 3, not including them because it's a less than, it's not an equal to. So between 1 and 3, our function is less than 0, okay? If you put in any value between 1 and 3, this number is going to be negative, okay? That number is going to be less than 0. Okay, now I'm going to use this same graph, and I'm going to ask a different question. Same function, x squared minus 4x plus 3. Okay, so we don't have to graph it again. But now I'm going to ask, well, where is it greater than or equal to 0? Now look at this. It is greater than or equal to 0. What that means, it's above the x-axis. Okay, greater than or equal to 0 means it's above the x-axis. Well, it's above the x-axis forever to the left of 1 and forever to the right of 3, right? Now, because we have an equal sign here, we're going to include the intercept. We're going to include where it equals 0. So this would be from negative infinity to 1, we're positive, we're above the y-axis or x-axis, and from 1, or I should say from 1 or 3 to infinity, we're above the x-axis. So to write that, I would say negative infinity to 1, that's here. Now we're going to include the 0 because we can be equal to 0 here. So we have to use a bracket, it's inclusive. Now look at 1, we go under 0, so we're the less than stuff up here, less than. And then at 3, so union, remember that's an or, we're going to include 3 because it's an equal to infinity. Okay? Questions other than, okay, let me see another example of that before it really kind of clicks. Okay? Let's do another. So the goal here is they're going to give you a quadratic, get 0 on one side, so it makes it an actual quadratic on one side. I graph them. Now your book, I think if you want to read the book, it goes about it differently. But we've done so much in graphing. We know how to graph these, and we've got a calculator. So graph it, and then just solve what it's asking. Where is it less than 0? Where is it greater than 0? Where is it greater than or equal to? And so on and so on. Okay, so let's do another example here. I think there's one in the book like this. I'll steal it. Well, maybe not. I'm gonna steal it anyway. I'm gonna make one up. So let's say we've got negative x squared. We want to know where that's greater than or equal to 4x. Okay, negative x squared, where it's greater than or equal to 4x. Now, just like before, I've got to move the 4x over. Okay. Now you're more than welcome to solve this out. If you just love solving for x-intercepts, right? Solve for an x-intercept, you set that equal to 0 and solve it. If you've got the quadratic quadratic solver in your calculator, that'll take 2 seconds. Not worried about it. I'm going to graph it just because I know I really kind of solve these based off the graph anyway. Now look, it's a negative x squared. This means we're going to be frowning, right? Negative, real technical terms there. Frowning quadratic. A negative x squared minus 4x. I'm going to graph that thing. Put it over here. Oop, it goes the other way. Okay, now again, what matters are the x-intercepts. I'm not worried about the vertex. That was a different section. The x-intercepts. It looks like it crosses at the origin, and I think at -4. I'm going to check that, so I'm going to go to table. Oh yeah, it definitely crosses at 0. That's 0, 0. And then scroll up. Oh yeah, -4 and 0. So I was right there. So 0 and -4. It goes up, comes back down. Something like that. Okay. Great. But now we've got to look back and see what this is asking us for. It's asking where is it greater than or equal to 0. Now our x-axis is here. We want to know where it's above the x-axis. That's the greater than. Where's it above the x-axis? Well, looks like it's above, or actually it is above the x-axis from -4 to 0, right? In between here, we're above the x-axis. So -4 to 0. So that's exactly how I would write it. Now, we're going to use brackets this time because it's equal to. So it can equal to 0. So I'm going to say -4 to 0. We're above the x-axis. Not too bad. And the reason this section, hopefully, is not that bad is because we're so familiar with quadratics, right? I mean, we are so comfortable with quadratics, it's not a big deal. It's really understanding the inequality aspect, the greater than or the less than, okay? Okay, do you guys have any questions? I'm going to give you a few examples, and I want you to work them. But before I do that, do any of you have any questions out there in Zoom world? Nothing? Okay. Let me give you a few questions then. I want you to work these better. So I'm just choosing them straight from the book, actually, guys. These are even ones. Let's see here. This is number 14. 6x squared plus x. It wants to know where is it greater than 1. And that's 14. And then 18 is 4x squared plus 1 is greater than or equal to 4x. So try those two. I might need another piece of paper for these. But try those two. This is 14 and 16 on page 420. So 14 and 16 on page 420. And I'll give you a few minutes. We've got time. Okay, let's do this one. If you're working, keep working. That's fine. The first one. Let's start here. I might have to use another piece of paper for this one, so I'm gonna just box it in. 6x squared. So first, I'm gonna move it over. Then I'm gonna graph it. I have a feeling the graph, it won't be as easy to see where the intercepts are, right? Okay, let me check. 6x squared plus x minus a 1. Graph. Eventually, oh, there she is. Okay. Looks like it's almost symmetric. But definitely, yeah, these don't cross at like 1 and 2, right? Okay, so there's a few ways to, well, actually, if I want to find out where the x-intercepts are, I'm gonna solve it. So x squared plus x minus 1 equals 0, right? That's gonna give us where we cross on the x-axis. So because it doesn't have a nice clear view. Now look, if you've got the quadratic solver in your calculator, you can just pop that in, 6, 1, and -1. Does anybody have that? Charlie, do you have it? You know, it's okay if you do. You're not. I mean, I don't consider it cheating. I mean, because you got to know how to use it. But if not, we're gonna solve it out the old-fashioned way, the factoring way. 6 times -1, that's -6. Adds up to +1, so that's 3 and -2. So I'm gonna write it as 6x squared minus 2x plus 3x minus 1. Factor out a 2x, and I'm left with 3x minus 1. I don't want to factor anything out of here, so I'm going to factor a 1 out. I get 3x minus 1 equals 0. So I wind up with 3x minus 1 times 2x plus 1. That's factoring trinomials by grouping, right? We did that the very first day of class. Set each one of those equal to 0. I'm going to worry about this one later, guys. Set each one of those equal to 0. 3x minus 1 equals 0. So x has to equal 1/3, right? Add the 1, divide the 3. That's the one to the right of the origin. And then we've got 2x plus 1 equals 0. Subtract the 1, divide the 2. We wind up with -1/2. Oh, yeah. See, fractional solutions not going to show up as easy. Now, we can check these, right? We talked a lot about that in 3.4. How, like, now if I go to, like, second calc, if I go to value and I put in, let's put in 1/3. You'll see I get back a y value of 0. So yeah, that one was right. And then same thing, second calc. There's a way to find intercepts here too. You're more than welcome to use it. I just don't do it. -0.5. Yep, also get a 0, right? So that means that these are our intercepts. Now let's think about this. So if these are our intercepts, and the way they're graphed there, we're trying to find where it's greater than 0. So if I kind of zoom in, I'm going to zoom in with the graph by drawing it. So we know it's 1/3 is right there. -1/2 is about right there. So we go down, we go up here, right? So we want to know, where is this above 0? Well, it's going to be above 0 to the left of the left intercept and to the right of the other intercept. Now this is -1/2 and this is 1/3. So now it's greater than, not greater than or equal to. So -∞ to -1/2, we're going to be above 0, or 1/3 to infinity. Okay, kind of cool. That one's a little trickier because it had fractional. That's why I chose it. It was a little trickier because of the fractions. Okay, so let's look at the next one. Questions about that one, guys? It took longer because we had to solve it out. If you've got that quadratic solver, look, I know Althea in the tutoring lab has that she can put in your calculator, okay? And she just pops it in, and then you can solve the quadratic equation in like one step, which is nice. Okay, any questions before we move on? Okay, so the other equation was 4x squared plus 1 greater than or equal to 4x. Now, got to move this 4x over. Now, when you do that, you got to squeeze it in between here to make it descending. I guess you don't have to, but if we have to do any factoring or anything like that, we need it there in the middle. Okay, so I'm going to do the same thing I've been doing. So again, this doesn't look like we're going to have nice solutions per se. So let's see, we have 4x squared minus 4x plus 1, graph it. Nope. What's going on there? Looks like it bounces. You guys see that? Okay, I'm going to zoom in just to make sure. So I'm going to hit the zoom. I'm going to hit the zoom in. I'm going to zoom in. Comes down. Boop. And it looks like it bounces off there, which is kind of cool. Hey, we know it has a multiplicity then. Really what that means is, oh yeah, this is a perfect squared quadratic. Okay, this is a perfectly squared quadratic. This is actually 2x minus 1 squared. You could write it like that, okay? It's because if you factor it, if you want to factor it like we did a second ago, you'll see that it's 2x minus 1 squared. But what that means is that 0, remember, if it has an even multiplicity, it means it bounces off wherever we have that 0, which is 1/2, right? 2x minus 1 equals 0. X equals 1/2 is the 0. That's kind of cool. Okay, so what we have going on then, the 0 is 1/2, but the issue is it just bounces. It never goes through the x-intercept, right? Now, we're trying to find where this thing's greater than or equal to 0. Well, is it ever below 0? No, it's never below 0, right? So if it's never below 0, it's always greater than or equal to 0. It never goes through the x-axis, right? And it's equal to, so it includes that endpoint. It includes the vertex, which is sitting right there on the axes. So this one is actually kind of interesting. It's negative infinity to infinity, right? Look, if it would have asked 4x squared minus 4x plus 1, where is it less than 0? You would have said no solution because it's never less than 0. It's always greater than or equal to 0 because it never dips below the axis. Kind of cool. It never drops below the axis. And I mean, like, look, if we go to the table, if you click second table, you'll see none of those numbers are negative, right? None of the y values are negative. They are always greater than or equal to 0. Okay? They're always greater than or equal to 0. I guess I have to go this way. Kind of cool. So yeah, I chose this one because it was just a little curveball. Okay. Do you have any questions about this? I'm going to assume you get it, or you just know you need to do the homework and then come back with questions. If you're doing this homework and you're like, oh my God, I don't understand what Mr. Schro's talking about. He doesn't make any sense. Oh, he's the worst teacher ever. Okay. You can use the book. The book teaches how to do this in a little different manner. And you're more than welcome to look at it. It's on it starts on page 412. And it's just a different way to go about it. It's called, it's like a test point way of doing it. I've got to choose one or the other or it gets real confusing. Okay. So it's one of those where I could teach you 10 different ways to solve this, but trust me, you'll wind up getting confused because of the number of ways I've chosen. Okay. Any questions? Let's do some other housekeeping stuff. Okay, hold on. Integrate. Okay, we're back. We're back here. Okay. So before I let you go, look, this is a short lecture because 3.7 or 3.6 is just a short section. We're going to go over 4.1 on on Thursday, but it's also another short section. It won't be too bad either. The bulk of this test really is 3.5. 3.5 could be almost like a whole chapter. It's that rational function section is a long section. Before we get going though, I want to talk about a few things because I've gotten some really good emails from the last test with students just not happy about the grade, which I understand. It was a harder test than the previous ones, but I need you also to know, look, I don't do bonus points. I don't do things of that nature, but your final replaces your lowest test grade. Okay. And I thought I made that clear at the beginning of the lecture, the section, or beginning of the semester. But I think some of it, some of you didn't think it mattered maybe at the beginning, but now it matters because you might not have done so well on this last test. So just realize your final does replace your lowest test grade. Typically the final is higher than at least 1 or 2 test grades. The final's cumulative and it's multiple choice. I give you like 2.5 hours to take it. We're not there yet, but it's not that far away either. Okay. So just realize your final will replace your lowest test grade. If you've taken 3 tests and this is your lowest, there's probably a good chance this might be the lowest test grade. Okay. If it's just not the lowest, I just don't replace anything. So let's say you make, A's and B's the whole semester, and then you wind up making a C on the final. It just won't replace a test. Okay. Very sure. It's still built into the average. It just doesn't replace a test grade. Okay. Does anybody have a question about that? You guys that are on Zoom, Charlie, does that make sense? Yeah. I just want to go over it. Do you have a question, CJ?
I just I was gonna tell you that that I'm sick. I took it while I had corona, and
Oh no.
I didn't realize, but I was like, I have to get this test done. It's due tomorrow, and
Oh
then
no.
I failed it, and then got my test results, and I was like, well, that was stupid.
Well, I hope you get better. I hope you get better, and definitely stay in Zoom.
I'm
But
trying.
just keep me updated. Keep me updated if you need anything. Just let me know. Does anybody any other questions or comments? If not, I'm going to let you go. This was a short section, but I'll let you go, and I will see you all now, guys. Today I'm going to be out of my office the rest of the day, but I'll be back tomorrow. If you have a question though, you email me. I can, if it's an easy question, I can email you right back on my phone. But if it's something more in depth, it's kind of hard. Oh, I guess I need to give you the homework. Yeah. Let's go back to the document camera. Come on. There we go. So for homework in 3.6, it's not that much actually. Numbers 1 through 27 odd. And that's on page 420, section 3.6. Okay. That is the homework. Okay. And I will see you all on Thursday. CJ, I hope you get better. I hope that you get over that quickly and you're back to normal soon. See you guys.
I have a question.
You're going to have to speak up just a little bit.